about 43 million people that live with blindness all over the globe. 41 million of them live in low and middle income nations with no supply or assistance. 3.5 to 5% of them are children, which is about 1.5 million, while 5% of them are young adults between 18 and 25. Both categories account for 8.5 to 10%. This institute is called An-Noor. It was the only one that used to provide braille materials in Sudan before it was damaged by the war.
I know 100,000 blind kids that can't read. Why? Because this is what the main Braille print room in Sudan looks like. This is Al-Noor Institute. It's a home, a school, a clinic for blind kids.
This trend does not only happen in Sudan, but all over Asia and Africa. The trend of early dropouts from schools is repeatedly seen in Asian and African countries that reaches to about 60% between poor-sighted students and 90% between completely blind ones. Even with assistive technology, challenges like unstable power supply, internet, and poor coverage stands on the way of benefiting from these technologies. Before knowing how we solve them, let's continue with the list of problems such as maintenance difficulties and environmental conditions that make them hard to maintain in these areas. We renovated the idea of text-to-speech conversion using OCR. This camera scans the text and it is then sent to the hardware for processing. Its body is made of nylon, which makes it stand out in harsh conditions, whether it's heat, dust, or rain. You might ask yourself, how is this pen different and how will it work in these countries? Because as I have mentioned earlier, this technology has been there for quite long now. And to answer these questions, let's take a look at what is inside the pen. Through a 10-watt solar panel that goes through some processing to convert this energy into electricity, it sends it to a charging board, then a battery, then there is a boost converter, and then this energy goes to a Raspberry Pi, that is the hardware, and the speaker and the audio amplifier that are used for sound output. There is the camera module for capturing the text and the micro SD card that is used to store the software. In addition, it can be conveniently charged by plugging it into any available power source. The initial cost of the first prototype is about $200. This includes components, manufacturing, and workers. These are electronics engineers, software, and mechanical developers. However, they are not really taken in account for the prototype because the team members did this work. Despite the need for collaboration with experts in Braille and hardware in the future, starting manufacturing in really big masses will significantly make the price per unit drop to about $90 to $115 per unit, and this is a very competitive price comparing to devices like Orcam Read 3, ScanMark Reader, C-Pen Reader 3, but it's not really very competitive comparing to Iris Pen Reader 8, since its price only ranges about $150 to $200. So why would you choose our device? Our device has a deep understanding for Arabic language and Braille Arabic language. It also charges using solar systems, so it doesn't really require electricity, which is something all these products don't have, with intentions to add AI assistance. So far we have seen that the pen has a durable design for everyday use, repairable components such as the battery and the hardware collection, and it operates offline, so it needs no internet connection. It has simple maintenance procedures and long-term value, so it doesn't need to be repaired or replaced every few months. And the discrete pen-shaped nylon shell reduces the waste by reducing the need of frequent replacement. These specifications help students and individuals gain more independent access to written and braille content, and it also eases educational access in developing countries, which successfully achieves the SDGs goal 4, which is quality education for all. It also contributes to goal 10 through offering independence and accessibility to more people, and enables them to be independent in most of their information gathering processes during life, alongside with an expanding access to affordable assistive technology. Now let's take a look at our future vision for this device through seeing aspects like product development, partnerships, and scaling and impact. Starting off with the product development we are intending to do. Developments like increasing the OCR accuracy, expanding the language package, optimizing the hardware, and adding AI features like object recognition and summarization. Now we move to the partnerships. Our goal is to secure the funding process and collaborate with educational institutes, NGOs, technology and shipping partners. Then we will hopefully start mass production by moving to our biggest and most important goal, that is expanding our impact to all these developing countries. We will find things like launching pilot programs, expanding to additional countries, and building local repair networks in these countries to help people get the most out of these devices. We will particularly put more efforts in collecting feedback from the users of these devices in order to develop them and satisfy the consumers. Finally is our biggest motive to build this whole project, which is making the pen available through governments and organizations, free for all people who need it, and free for students who can't afford to proceed their education. Because as a team, we believe education shouldn't be limited by geographical locations or financial statuses.